Hi everyone, it's Alice. Welcome to another GRE video. Today we're going to be talking about the quantitative section of the GRE, and the topic is greatest common factor. Before we get into all of that, I want to remind you that I am, yes, still meeting with people free for 30 minutes one-on-one. You can find the link down below in the pinned comment if you'd like to meet with me to talk about anything GRE related, and I will be more than happy to meet with you. If you're watching this video in the future, the pinned comment will also let you know if I'm no longer doing this. Don't forget to like and subscribe, and let's get into it. So if we break down this term, greatest common factor, into its component words, we're basically looking at this. Greatest means the largest, obviously. Common means something that is shared. So when we're talking about the greatest common factor, we definitely have two or more numbers to begin with. And don't forget that a factor is a number that divides evenly into the original. So for example, if we have the number 10, its factors are going to be 1, 2, 5, and 10. So those four numbers divide evenly into the original, into 10, so all of them are factors. When we're talking about the greatest common factor of two numbers, for example, we're talking about the biggest factor that both of these numbers share. Technically, if you have no idea how to do this, you can write down all the factors of all the numbers you have to compare and figure out if any of the factors are overlapping and which factor is the largest. But obviously this is going to take way too much time. So what you really want to do is use prime factorization. If you're unfamiliar with this technique, I have a video explaining exactly how to do it, but in essence, it is breaking down a number into only prime numbers so that you can combine them and come up with all the potential factors that go into a single number. You can find the link to that video in the cards and the description. Most of the time, prime factorization is done with trees like this. So if we're looking at, for example, the number 24, the prime factorization of 24, which is the combination of only prime numbers, is 2 times 2 times 2 times 3. And if we have 30, for example, that can be broken down into 2 times 3 times 5. Don't forget that on the GRE, you will have access to a basic calculator, so that can help you out in doing prime factorization, but it really helps to be pretty familiar with rules such as even numbers are divisible by 2, which numbers are divisible by 3, etc., etc. Prime factorization is also useful for least common multiple, which, if you're interested, I also have another video on that. So now, if we are looking for the greatest common factor of two or more numbers, we will start with 2 here. We want to first do the prime factorization of all the numbers involved. What you want to do after that is list all the factors side by side like this, so you can see all the factors that overlap. Now, if you look at all the prime numbers here, you can see that any numbers that overlap are going to go into coming up with your greatest common factor. So if we look again at the 24 and the 30 example, you can see that both of these numbers have a 2 in their prime factorization, and they also have a 3. So because these are factors, we want to multiply the 2 and the 3 to make 6. And what we come up with is a greatest common factor of 6. So 6 is the largest number that divides evenly into both 24 and 30. That is a pretty simple one that you might not have needed prime factorization to solve, but hopefully that gives you an idea of how to do it. As for all of the rest of the numbers in those prime factorizations, you can basically ignore them. They are not important, and you want to only focus on the factors in the prime factorization that all the numbers you're comparing share. So let's go through a few examples to give you a better idea of what this looks like. The first example that I have is a comparison of 8 and 12. So if we break down these numbers into only their prime factors, we can see that 8 equals 2 times 2 times 2, and 12 equals 2 times 2 times 3. If we put these side by side and we look at the numbers that overlap, we can see that both prime factorizations have two 2's. Now, 2 times 2 equals 4, and you can check this by seeing if 4 evenly divides into 8 and 12, the original numbers. You can see obviously that 4 does go evenly into both of those, so you know that the greatest common factor of 8 and 12 is 4. We have another example here with 26 and 27. If we break both of these numbers down into their prime factors, 26 equals 2 times 13, and 27 is 3 cubed, or 3 times 3 times 3. Now here we have a little dilemma because the prime factorizations of both of these numbers don't have any numbers in common. Now, does that mean that there is no greatest common factor? Not quite, because if you remember, 1 does evenly divide into all whole numbers, and because of that, we have a greatest common factor of 1, because no number evenly divides into both 26 and 27 that's larger than 1. Now, for our next example, we have 10 and 100. So here, hopefully you already know that 100 is divisible by 10 because 10 times 10, or 10 squared, is 100. But if we break this down into our prime factorization, you can see why. 10 equals 2 times 5, and 100 equals 2 times 2 times 5 times 5. Now, the overlapping factors for both of these are going to be 2 and 5, 1, 2, and 1, 5. And if we multiply 2 times 5, of course, that equals 10. So the greatest common factor of 10 and 100 is 10. Now, for our last example, we have numbers that are slightly larger, 84 and 96. If we break these down into their prime factors, we can see that 84 equals 2 times 2 times 3 times 7, and 96 equals 2 to the 5th power times 3. Now that means that it's 2 times 2 times 2 times 2 times 2, 5 times 3. If we look at the overlap between the factors, we can see that both of these have 2 2's and 1 3. And 2 times 2 times 3, of course, equals 12. So 84 and 96 are both divisible by 12, and 12 is the largest factor that both of these numbers share. I think overall, greatest common factor is not too difficult, but if you would like more practice, you can basically put together any two numbers and put them in Google. If you need some more help, I have a few examples right here. So here, look for the greatest common factors of 27 and 87, and look for the GCF of 120 and 264. I will have answers for these after the outro. Hopefully this covers greatest common factor for you. It is just an extension of prime factorization and understanding that the greatest factors are basically anything that those two numbers you're trying to compare share. If you have 3 numbers, make sure that all 3 of your numbers share all of those factors as well. Thank you so much for watching. If you learned something, let me know in the comments down below. Don't forget to like and subscribe. Check out all of my other GRE content. Meet with me. I would love to meet with you. And if you did those practice problems, here right now are the answers to those. Hopefully you got them right. If not, maybe we can talk about them. Thank you so much for watching my video. I hope you have a great day, and I'll see you next time. Bye.